3, 2, 1, ignition. And this is the LC. Minotaur launch vehicle is carrying the AA-2 launch abort system for a full stress test.
Abort initiation.
Pyros 1 and 2 discharge both sides.
Good chamber pressure.
Good control. Settling phase. Jettison.
Pyros 3 and 4.
We're out here testing these instruments to collect atmospheric wind, aerosol, and water vapor data. Doing this to understand how accurate these instruments are, and also to understand how we might be able to take these instruments to space someday.
6-0, releasing drop zone.
Hi everyone, here we are on DC-8. We're flying about 2/3 of the way through our third flight, start flight number 3. As you can see, students are on board, as well as about a dozen or so different instruments.
What is this showing versus this graph here?
FireX-AQ for short. The goal is to track smoke as it crosses North America, taking air samples ranging from high in the sky to down on the ground where people are breathing it.
The DC-8 here at NASA Armstrong has supported Operation Iceberg since 2009. This will be our 7th campaign.
Air Lucy, it is designed to measure the light reflected off the moon, and it flies in the ER-2 high altitude airplanes.
Flying high in the Earth's atmosphere with SOFIA, the world's largest airborne observatory, scientists finally detected this elusive molecule called helium hydride.
Report for terminal count and launch. Capsule.
Go.
Booster. Go.
SPLICE is developing a family of sensors that are required to land safely and precisely on the moon, Mars, and any other destination.
All right, ready? Here we go. Here we go.
CUS, we are in between Lake Bed 1.5 and 1.8 US.
Anyone on the controller? Everything look good to everyone?
3, 2, 1, release.
Okay, we'll be coming to the right and then back around to the left.
The X-56A project is intended to enable the utilization of light-efficient wings by development of flight control technologies to suppress flutter.
And we're coming to the left.
This was one of the most heavily instrumented wings we've ever tested. There was about 10,000 sensors on a wing, which included fiber optic strain sensing, conventional strain sensing, displacement sensors, load sensing, and also inclinometers.
Chase A72 slowing to 134.
The project I'm working on is the unmanned aircraft systems integration into the National Aerospace System. The point of this project is to integrate these UAS into airspace occupied by human-piloted aircraft.
Everybody stand by, please. Tiger 50, where are you calling? Number 8.
The use of this project is going to go for a long time because it's going to establish a fundamental data set on how pilots breathe in a tactical environment.
This particular antenna, we're trying to reduce interference on the ground, and we have a flight test campaign to explore exactly how well we're able to control the interference of this phased array type antenna.
We're really excited. We have this wing that we've been designing for years that's been finally built and delivered, and now we're testing it to see if it matches the performance that we need for the X-57 vehicle.
X-57, it's a manned electric airplane, and what we're doing is developing technologies related to electric aircraft.
Right now, conventional supersonic aircraft are just way too loud when they're supersonic. It'd be very disturbing for people. But we're sure that we can make planes that are quiet and still be supersonic, so we can reduce flight times in half without disturbing people.
Ultimately, the X-59 will be creating a quiet sonic thump.
So what we're doing now is we're going to take what we learned from these experiments and we're going to apply them to the X-59, which is going to ultimately be flown in the year 2021, so that for the first time we can get regulations on the books in the United States of America that say you can fly supersonic.